Hey Internet, welcome to Thermodynamics tutorial. This is a made-up question not found in your textbooks. I'm going to show you how to read the thermodynamic property tables. So we have the water table in metric. So we want to find the missing categories. Okay, step 1, there's no free body diagram. However, there is a color key. So given is cyan and the answer is green. Step 2, list all the given variables, find the unknown. So I just translated the table into word form. So we're looking for temperature and phase for the first one. For the second one, we're looking for pressure and internal energy. For the third one, we're looking for internal energy and phase. For the last one, it is temperature and phase. The last one is a little bit tricky. So when we get to it, you will understand what I mean by a little bit tricky. Okay, so step 3, find the temperature and phase using the clues. So we're given pressure and internal energy. So step 4, we're going to go to the property table. This one is a custom one for this question since it's made up. Okay, so what normally you would do is you either go to Google and search it up, look in the back of your textbook, or you can just read the pinned comment if you got the textbook. I can't tell you which textbook. Okay, so for this custom thermodynamic property table, we go to the pressure table because that's what they give us. Then we compare the internal energy with the internal energy section. So 1450 is in between 604 and 1948. So what that is telling us is that it is a saturated mixture because it's in between the two. And since it's saturated, we're going to use the saturated temperature, which is 143.61. So depending on your textbook, your values may differ a little bit. So when we come to later questions, there will be a difference in values depending on what edition or what textbook you're using. Okay. So here is step 5. So the answer is 143.61 degrees, and it's a saturated mixture. So that is the first one done. So I'm just gonna go in order, go descending. So we've done the first one, we're gonna go 2, 3, and 4. Okay. So they're all on one page. So as you can see, this one is the first one, and then the next one will be the second. So they give us the temperature and the phase. So it's a saturated vapor. We want to find the pressure and the internal energy. So since they give us the temperature, we go to the temperature table. Once again, you can look up your table. So this is just a condensed version. Once again, custom made. Alright, and I say this just because for, I guess, legal and copyright reasons. Okay, so we go to the temperature property table for water, of course, and then we go to saturated vapor. So they want us to know what the internal energy is at that phase. So directly down, it'll be 2601.3 kilojoules per kilogram. And then since it's saturated, we just use the saturated pressure, which is 2319.6 kPa. Okay, so step 8, the final answers are here. Alright. So this is number 3. I'll just keep coming back and referring to this table. So we're on to the 190 degrees now. Alright. So for viewers and students that have done the concept questions, all 20 of them, before watching this video, then it may help you a little bit. So we got the temperature at 190 degrees and the pressure at 2500 kPa. We want to find the internal energy, U, and we want to find the phase. Once again, we go to our textbook, our property table. So since they give us both temperature and pressure, which one do you use? So you would use the temperature one, and then you would compare the pressure. Okay. So we go to the saturated pressure. We compare. So 2500 is greater than 1255.2. So what that tells us is that it is a compressed liquid. So for compressed liquid, we approximate to the saturated liquid. So we will just take the value for saturated liquid. So it'll be 806 kilojoules per kilogram. So step 11, the final answers, U is 806 kilojoules per kilogram, and it's a compressed liquid because the pressure is greater than the saturated pressure. So note that even though this is a made-up question and this is a custom-made property table, if you have a real textbook and you go to the back, depending on what edition, you may get a different value. So if you got a 10-year-old textbook, 2015 and older, so older being 2014 and below, you'll have an answer of 805.15 kilojoules per kilogram. So anything above 2015, so 2016 onwards, you'll get 806. They change the values from time to time. Okay. So step 12, we want to find the temperature and phase using the clues. So this is our final question. So we're over here. Okay. So they give us the pressure and they give us the internal energy. So we're going to go to the pressure table for water. Then we're going to check the internal energy and compare. So we go to 4000 kPa for water. Then we go to the internal energy. So 3040 is greater than 2601.7. So what this indicates is that it is superheated because it's above saturated vapor. So the next step, we need to go to the superheated table. Okay, so note that we need to go to the 4000 kPa and then check the internal energy of 3040 kilojoules per kilogram. Note that in your textbook, they will have it as 4 MPa. Okay, so when you find your 4 MPa superheated water table, you will have these values, something like this. This is custom made. So when you go to your table, and like I said in the beginning, this final question is a little bit tricky. So what you notice is that 3040 is in between 3011 and 3100.3. So what do you do now? You have to linear interpolate. So for most students that are taking thermodynamics, I'm sure you've done this in Calculus 1, but for students that have never linear interpolated before, here is the formula that you use. And I am using the ratio method. Okay, so we've got this max A minus min B divided by max A minus the given value is equal to max A2 minus min B2. And then we've got the unknown, which is the temperature that we're trying to find, minus min B2. So this is just the general formula. Let's put it in practice. So step 15, we're going to find the temperature. So on our left hand side, it is the internal energy, U, and the right hand side is the temperature. You can switch it if you want to. However, I'm just following the general formula. So you've got max A. So max A is going to be 3100.3 minus 3011. So that is min B. Okay. And then the given value for us, it is 3040. Okay, right here. So on your right hand side, it will be your temperature. So 500 minus 450. We're trying to find the temperature at 3040 kilojoules at 4 MPa minus 450. So when you linear interpolate, it will be 466.2 degrees. So step 16, find the temperature and phase. It is 466.2 degrees Celsius, and the phase is superheated. Okay, so in exams, assignments, and midterms, they really like throwing these questions because one, it requires 3 steps. You need to first identify that it is a superheated table. So you got to go to your saturated, check that it's not saturated, go to superheated. Then when you find out it's in between, you got to linear interpolate, and then you can find the final answer. So professors really like doing that. I don't really think that's a good way to test students. It's more like testing students' ability to do math rather than understanding thermodynamics, but that's just my own opinion. Alright, so now before we leave, I highly recommend that you save this video onto your PC, just in case this video gets taken down while I follow all copyright laws. Sometimes things happen. You can do this by using snipping tool. If you never used snipping tool before, follow these instructions. If you're on a Mac, use the Mac equivalent of snipping tool. So click on the icon in your taskbar. If it's not there, go to your Windows search, type in snipping tool, open up the program. Once open, click on video option, click on new. Left click and drag the rectangle to cover the YouTube screen. Hit the start button in snipping tool, wait for the countdown, hit the replay button on YouTube, let the video finish, Hit the red square and snipping tool to stop recording and then save your video. Thanks for watching. Hope you had a great day. Be sure to like and subscribe. Share with your friends because this is a made up question, so they probably won't be able to find it. If you got questions or comments, or if you find a mistake in the video, leave it in the comment section. I'll get back to you as soon as possible. So disclaimers, while this is just reading the table for the final question, there is a little bit of math, so I do make mistakes sometimes. I encourage you to solve it yourself and see if you get the same answer. If you want to support me, become a member or drop a super thanks. Until next time, see ya.